Well, hello again. This is Bob N1 KPR, and today we're looking at the third atomic clock prototype in this series. If you look back at some of the YouTube presentations, you'll see that there is a dual version of this particular clock, as well as the very first prototype, which had extended switching and timing features for broadcast studio work, synchronizing with syndicated and local broadcast switching, and so on. This particular one is intended to be the master clock that can drive slave units or act as a standalone in the studio. Right now we're in the basement, and we don't have a signal acquisition or sync with WWVB, which is the 60 kilohertz time-based digital signal from Fort Collins in Colorado. But if we hook it up to the external antenna, the ferrite loop antenna, we'll achieve sync over here in a few minutes. Anyhow, this particular unit, being the master, has a typical 6-digit display, which we will be setting up as the GMT, UTC time in 24-hour format, although it is switchable to 12 or 24-hour format here on the East Coast. It will also track daylight savings time with no problem. This model, I don't know if we can see it so good, has the signal strength meter, which we're looking at here, and also the demodulated audio level can be monitored here as well. The activity, let's get the light better here. Incoming S meter activity is a red and green. Instead of using bicolor LEDs, we used separate LEDs. It's a little more graphic and easier to read at a glance. And here you can see the bit stream, the data stream from Fort Collins at 60 kilohertz coming into the system. Here is the demodulator's 1 pulse per second sync output, which is headbanging against the PLL with the internal oscillator, so it's always, even when it's in the free running mode, it's always pretty accurate. An indicator for antenna communications to see that we're drawing current to the external antenna, and as you can see, as we load it up, we would lose the we're drawing too much current, so that's an indicator that it's either connected or not connected. Let's see, we have a reset here so that you can actually drop it out to confirm that there is antenna continuity. And then again, of course, the signal integrity, which means we're receiving accurate data. Again, we're in the basement, so we're not. And the update cycle, which is every hour. If we receive a signal once an hour from Fort Collins, this will be green. We also can monitor, we have audio in here, we can actually monitor the incoming RF bit stream, and here it is. Now if you notice, there's a cadence to it, which is the repeating 1 pulse per second plus and minus bit stream. Now listen for the cadence. All right. And also we can go over and listen to the demodulated signal that the receiver has done its job, and it's feeding digital signal to the display unit. And that would be the AF from the demodulator at the end of the IS strip at the detector, and here's that. I think that's audible. That's pretty much a perfect 1 pulse per second audio indication that we're getting the proper bit stream. Okay, so that's basically it. Again, we can change the antenna loading to get uh, things right at the up on the tower, and we have drain, and you can see the indication here. Drain, if there's any static buildup and it blocks the receiver for any reason, we can do that, and a reset function so that we can just start the whole listening procedure over again, which are seldom needed. But there you are. This is the third and hopefully the final prototype of a real true time WWVB from Fort Collins, Colorado. True time receiver. My name is Bob, N1KPR in Shelton, Connecticut, and thanks for watching.